All right, time for a square. So remember, a square is a special parallelogram that has both 90-degree angles and 4 congruent sides. So those are the things that make it a special parallelogram. So it's basically a combination of a rectangle and a rhombus. And so it takes all of those properties. So it's going to have the properties of a parallelogram, which, if you remember, are opposite sides are congruent. And I'm going to put the same mark here because it's a square and all 4 are congruent. Opposite angles are congruent, but it's a square, so they're all 90 degrees. Remember, diagonals bisect each other. Bisect means cut in half. So this piece is congruent to this piece. But since it's a square, all of them are congruent because in a rectangle, diagonals are perpendicular. Are congruent. And in a rhombus, diagonals are perpendicular and they bisect the angles. So it's all of them, the properties of a parallelogram plus the properties of a rectangle plus the properties of a rhombus. Okay, so I'm going to say it again for the 100th time. Properties of a parallelogram. Opposite sides are congruent. Opposite angles are congruent. Diagonals bisect each other. And consecutive angles are supplementary. Properties of a rectangle. Diagonals are congruent. Properties of a rhombus. Diagonals are perpendicular. And diagonals bisect the angles. So a lot to remember, but you need to actually remember. So memorize that stuff, guys. Also, you'll see a whole bunch of right triangles in here, so you'll know you'll be using Pythagorean theorem and trig sometimes. So let's get to the examples. If BCDE is a square, we want to find each missing angle or measure. And check this out. We only actually have one piece of information, just one. We know that this half of a diagonal is 8, but diagonals bisect each other, so the other piece is 8. Diagonals are congruent, so this one also has to be 8 and 8. We also know that in a square, diagonals are perpendicular, which creates a right angle here. And because this is isosceles, this little triangle right here, can you see it? That one's isosceles. We know that these two angles, base angles, have to be congruent. There's 90 degrees left, so 90 divided by 2 is 45 and 45. And so are all of them in a square. Because the angles are all 90 degrees, they are all bisected. And you see a whole bunch of little triangles in there that are isosceles. But they are also right triangles. So if we check out this one, we know 2 sides of it, and we want to know the last side. This side is the hypotenuse because it's across from the right angle. So we would do the Pythagorean theorem to figure out that missing side. And I'm going to put this, you know what, I'll do this way, just so that you guys see it another time. We're going to break this down into simplest radical form. So that would be 2, which is prime, times 64. 64 is 2 times 32. 2 times 16. 2 times 8. 2 times 4, which is 2 times 2. So there's all of our primes. Anytime we have 2 of the same, we write it down. Two more, and a leftover. So 2 times 2 is 4, times 2 is 8, 8 root 2. That's the best answer for that side. And it's a square, so all the sides are congruent. All right, let's check it out down here. CE, is this whole diagonal. Each piece is 8, so 16 would be the whole thing. BC, 8 root 2. CFD. CFD, 90 degrees. That's a popular question, by the way, when there's no information given, just to know that that's 90. And then DBE is 45. New problem. If QRST is a square, we want to find RT. How long is this piece? Well, we know that this is a 90-degree angle right there, and it's a square, so this has to be 18. And check this out. We have this whole right triangle here, half of the square. So couldn't we use the Pythagorean theorem to find the length of RT? And honestly, 18 squared I do not have memorized. 324. This equals, in decimal form, approximately 25.5. So the length of RT is 25.5. Now, because of all the experience I have there, and something we're going to learn later in this class about special right triangles, I know that this side is also 18 root 2. So if I do 18 root 2, I should get the same answer. Now, I know that from experience. You will soon know that from experience. But for right now, the Pythagorean theorem does its job. PQSR is a square. Solve for x. Well, it's a square, and all of these are 90-degree angles. And the diagonals bisect the angles, which means all of the little ones are 45. So wouldn't it make sense that 6x minus 21 is equal to 45? Again, this is one way to do it. It is not the only way. So if you want me to explain it another way, just let me know, and I will meet you in office hours. X equals 11. Any questions? All right. This one tells us that the length of the diagonal is 46 and wants us to tell all of the other measurements. So this one's going to look a lot like this one up here. The diagonal is 46, so I'm going to focus on this part, LON, just so you can kind of see what I'm looking at. And this is 46. We know these two sides are the same, so I'm going to make them both x because it's a square. So this time x squared plus x squared equals 46 squared. This time we know the diagonal, the hypotenuse, but not the actual side length. So 2x squared equals whatever 46 squared is. 2,116. Divide both sides by 2. X squared equals 1,058. And the square root of 1,058 is 32.5. Of course, you could put that into simplified radical form also if you want. 32.5 all around. We also know that all these little ones are 23. Okay, and I think we got them all. Let's see. OM would be 46 also. PN, 23 because it was bisected. ON, 32.5. And MN also 32.5. Okay. All right, I hope that kind of got you started. Good luck on the square problems on the worksheet.